So we're going to continue on with this concept of a hyperbola, and we're going to look at the equation of a hyperbola, take maybe a more little analytical approach to this whole thing. If you take a look at these two right here in black, those are going to be the standard form equations of a hyperbola. The most important thing, I think, is to look at which term comes first. There's always a minus sign as opposed to a plus sign for an ellipse. And here the y term comes first. So whichever term comes first is going to determine which direction it opens. So if the x term comes first, followed by a minus sign, then you'll have a left and a right, left and right opening ellipse, or excuse me, a hyperbola. And then in this situation where you have a y coming first, it's going to open in the y direction or up and down. Always going to be a minus sign, always equal to 1. A little different than an ellipse for a hyperbola, that a squared will always be under the very first term, and b squared will always be under the second term. So those won't change. They'll just stay a squared, b squared, and b squared. What does stay the same is the center. So the center of this thing is going to be hk. Might be able to write that somewhere, maybe here on the top. So for each one of these, the center is just hk. Keep in mind that the k always goes with the y, so that does change sides. It just stays with whatever variable it's with. And then also, and I wrote this down here a little bit, so I'll slide this up for you. A is going to be from the center to a vertice, and then C is going to be the center to the focus. The equation on the right-hand side will give you the value of C if you know A and B. B is mostly used to determine and help determine the slope of an asymptote. So let's take a look at this first one together. And we're going to look, and first of all, it opens left and right. So what we can do is maybe just kind of draw this real quick. It's going to look something like this. Now, we don't know where the center is. It's just H and K and everything else, but it totally will open left and right. A is just this distance here between the center and a vertice, and then B is going to help us to form the asymptote. So when we write the equation of the asymptote for a hyperbola that opens left and right, it's just going to be y minus k is equal to, and we've got both the positive and negative slope. If you remember back to the last video, I'll pull that up right here for you. These slopes right here were just exactly the opposite of one another, so it's going to be plus or minus. And in this case, the b is underneath the y. We want to do the change in y over the change in x, which is a, and that's going to be x minus h. So all this is this is point-slope form of a linear equation, and that's an asymptote, would just be a straight line, and the slope is b over a. Y minus k stays the same, and x minus h stays the same. If we take a look at a hyperbola that opens up and down, in this case, for the asymptote, it's the same thing. It's y minus k here is equal to, but now the a is underneath the y, so it's going to be plus or minus a over b. B is now underneath the x, so the change in y over the change in x when you write slope, and that's going to be multiplied by just x minus h. This hyperbola, if I draw that in blue, might look something like this. Don't know exactly what it looks like. I'll wait to the examples in this learning target to kind of get into the nitty-gritty there. But basically, what you want to know is whatever variable, or excuse me, whatever number is by the y, that's the y part of the center. Whatever number is by the x, that's going to be the x part of the center. Remember to do the opposite of whatever numbers are there. A squared is always underneath the first term. We always have a minus sign for a hyperbola. And then b squared is always under the second term.